Hello students, I am Nilanjana Sanyal. Welcome you all to my channel in its online math classes. Our today's topic is combining logarithms with different bases. We have learned how to combine logarithmic terms which had the same base and we gave the result as a single logarithmic term. We have learned that using the multiplication law for logarithms or the product rule of logarithms. But in our today's session, we will be given multiple logarithmic terms and they will be having different bases and we have to combine them to give a single logarithmic term. How do we do that? We have learnt about the change of base rule, so we will be using that property of logarithm to do this combining part. Okay? To get a single logarithmic term from the given logarithmic terms which have different bases. And we will be solving a single question in our today's session because it is very similar to the previous questions that we have solved which had the same base. The only difference is in our today's session the logarithmic terms will be having different bases. Okay? So without any further delay, let us start with our today's session. Let us first of all look at the given question. Write as a single logarithm log of 6 to the base 5 plus log of 5 to the base 6. So the first term is having a base 5 and the second term is having a base 6. And we have to combine these two terms to give a single logarithmic term. Okay? We may have the single logarithmic term to base 5 or you may have it to base 6 or you may have it in some other base. It's not given that you have to have the single logarithmic term to this base. If the question contains that what should be the base of the single logarithmic term, then we have to change it to that base. But over here, we are not given that condition that we have to get the final logarithmic term in some base. So it is our discretion to choose what will be the final base. What will be the base of the final logarithmic term. We can choose that to be equal to 5. We can choose that to be equal to 6. We can choose a separate base, a totally separate base. Okay? And in our today's session, I have chosen a totally separate base. I have chosen the base to be equal to 10. So I have changed the base of both these logarithmic terms. If you want, first of all, let me tell you how am I changing the base to 10. Log of 6 to the base 5. I want the base to be equal to 10. So it is log of 6 to the base 10. The argument, it is above the base. You see, base is obviously below. It is the subscript. So it is below the argument. So the argument comes in the numerator and the base goes down in the denominator. Because this is what the students get confused. They often do not remember which one to be taken in the numerator and which one to be taken in the denominator. The very positions tell us which one to be taken in the numerator and which one to be taken in the denominator. Okay? So it is log of 6 to the base 10, which we do not write explicitly. That is log of 6 over log of 5. And this is also converted to base 10. So it is log of 5 over log of 6. If you want to keep the base of the final logarithm as base 5, then you keep this term as it is and you change the base of this term to base 5. Or else if the final logarithm has to be given in base 6, you keep this term as it is and change the base of this term to 6. In this question, I have taken a totally separate number that is 10 as the base. It is our choice because they did not give us any condition. If the question contained that condition, that you have to give the final logarithm to this base, then we would have converted the terms to that very base. But we are in a liberty to choose the base of the final logarithm for this question because it is not specified. And I have taken the base to be equal to 10. We have not done the natural logarithm. We will be doing the natural logarithm which has a base e. You can convert to natural logarithm as well. Okay? But since we have not done the natural logarithm part till now, I have converted it to the base 10. And this is log of 6 over log of 5 plus log of 5 over log of 6. This is equal to 1 over log of 5 times log of 6. We can write this in this form, 1 over log of 5 times log of 6 plus 1 over log of 6 times log of 5. Why are we writing this expression in this form? Because in order to combine logarithmic terms, we know that we cannot combine fractional logarithmic terms. Means we are having a logarithmic term in the numerator, another logarithmic term in the denominator. And if we just take the LCM, it will be log of 5 times log of 6. And this will be log of 6 whole square plus log of 5 whole square. Doesn't really help. So what we do is we separate them so that this becomes the coefficient of log of 6. And this 1 over log of 6 becomes the coefficient of log of 5. Because we have to combine them and we have to get to a single logarithmic term. So we have to get some coefficient which can be transferred to the power position. We know if we have to combine logarithmic terms, the coefficients should be equal to 1. Therefore, first of all, we have separated the coefficients of both the terms, and then we will be taking these two to the powers of the 6 and 5. We will be writing 1 over log of 5 as the power of 6 and 1 over log of 6 as the power of 5. Why can we write this? Because 1 over log of 5 or 1 over log of 6, these are basically numbers. If you use a calculator, you see what is 1 over log of 5, you get the value as approximately equal to 1.43 up to 3 significant figures, and 1 over log of 6 as 1.29 up to 3 significant figures. So these are, if you had 2 times log of 6, you could have taken this 2 to the power part of 6 and we could have written log of 6 to the power of 2. The same thing, instead of a very known integer, we are having a fraction type of a thing, but doesn't matter. It is also a number. Basically, it is also a real number. We can take this and make it the power of 6, and take this 1 over log of 6 and make it the power of 5. Now we are having the coefficients of these two logarithmic terms as 1, so we can combine them using the product rule, because now the base of both the terms are the same. Now we can use the product rule to combine them and get a single logarithmic term. It is log of 6 to the power of 1 over log 5 times 5 to the power of 1 over log 6. Okay. Of course, you can get the numerical value of this and give log of that value, but you can keep the answer in this form as well. Okay. So this is how you get to a single logarithm when the bases are different. First of all, change the terms to the single base. The base can be one of these two bases, or you can choose a third base. And then when you make the base the same for all the terms, proceed as you have done before using the product rule, combine them. First of all, you have to, of course, if you don't have a coefficient equal to 1, You have to take the coefficients to the power place and then combine the terms. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.